And then we'll enter into the second principle. Let's just take one more extensive question, then we'll enter into the second principle of solving differential equations. Okay, so I'm looking for where's an empty space. Now, this is empty. Now, I think this is going to take a little bit. Now, for this particular one I want to solve, let me just bring out the equation. Y is equal to the square root of x minus 1. Now, for this particular question, please, I hope you know how to work with surds, because I'm going to apply a surd rule in solving this particular question. Now, let's move on. So first of all, I bring in my little change. Y changing x will be what? Anywhere I see x, I put what? X changing x, right? So, or x delta x, whichever way you want to call it. X delta x minus 1. And let's call our equation 2. This is our equation 1 already. So we do equation 2 minus equation 1, right? And that will be y plus change in x minus y is equal to what? X plus change in x minus 1. Then minus x minus 1. Okay, now what do we do here now? Okay, first of all, let me first cancel out this part. This one is out, so we have that our change in x is equal to, oh, that's change in y. If we went there, writing change in x, this is meant to be change in y. Sorry for the mistake. Change in y, this change in y. Here is then going to be, this is where you have the change in x in the other side, carrying the x. I'm still putting it. It's like this is the force of habit too. Okay, so change in y. I have to even make it very bold. Okay, so now continuing, what do we do here? We do what they call rationalization of a surd. In surd rule, whenever you have a surd A, you can rationalize this to have a denominator that is not, that you can take away this. Rationalization means taking away the surd from either the numerator or the denominator. So if you have a numerator that has a surd, and you want to take away that particular surd, they call a surd roots. Roots are actually called surd. If you want to take away this root out of this place, and you don't want it to be here, you do what they call rationalization. So what do? You just multiply it by the root up and down. So therefore, if I have this as root a times root a times root a, then what happens here? This will cancel out this particular root, and what do you have here? Just a over root a. It's still the same answer. It's still the same answer, but it's just different way of appearing. So root a is still the same thing as writing what? A over root a. It's actually the same thing. It's just that this particular case, we rationalize it to get this. The same thing also, if you want to also rationalize a denominator that is a surd, that's if I have it as a over root a now, and I don't want my root to be in the denominator, I can also do what? Cancel out this one by rationalizing. So this root that is the denominator, I just multiply this by up and down again. So that will be this. We'll cancel out this. Remember, the root will cancel out the same root since they're the same value, and you have what? A root a over what? A. Oh, then that means what it means that this particular question is a little bit different. So for this one that we solved, for this one we solved, I think I'm going to make a correction to it, but let's just continue. So here will be what? A root a over what? A. And if you say it is over a, what happens? A cancel out a, and what do you have? Just only root a. And we're back to what? We're back to the same thing again. So you can see that you can rationalize a denominator that is a surd, or you can rationalize a numerator that is a surd by just multiplying it by the same surd that looks like it. But what of the case where you have something like this appearing, two surds adding or subtracting each other? Now that's what we call still rationalization, but you call it a conjugate of that surd. First of all, you rationalize their conjugates. So let's say we have root a. This is just a side discussion. Let's say we have root a plus root b, and you want to take away this surd from these sides. How do you do it? You multiply it by the conjugate. The conjugate is actually the same surd, but change the sign. So it will be what? Root a. This is the conjugate of this. So let me take away this equality sign. The conjugate, let's put this one in bracket. The conjugate will be what? Root a minus root b. So you just, it's carrying a different sign. And then we rationalize it also. So it's going to be the same thing also up and down, root a minus root b. And therefore what happens here, when you multiply a value that are the same in figures but different in signs, is what we call the difference of two squares. Difference of two squares. What's the difference of two squares? Let me explain it here. The difference of two squares states that if you have your a plus b multiplying your a minus b, it will be what? Just open it out. It will be giving you a square minus b square. But if you want to check it out here, you can see it here that when you open this, you can do the solving yourself. I don't want to go too long. I don't want the video to extend more than 20 minutes. I think I've only spending up close to 20 minutes already. So The same thing will also happen here. This one will become what? This particular one here will become what? A root a square, just like how this one's just having an a square, and then minus a root b square. But remember, when you take square of any root sign, it cancels out, right? So it's actually what? Just a minus b, and our root signs are off over what? This particular one goes under it, root a minus root b, and we are back to a numerator no longer having your surd, no longer having the root sign. So this is just all about conjugation, because we'll actually apply this thing that we just did now from what we just showed here. So let me take away everything I've just done here and take it away. So like how they told Jesus, take him away, take him away. Crucify him, crucify him. Okay, so let's take this away. It's not going out. Okay, so this out. Now let's continue. So I will take the conjugate of this and rationalize it. So that will be x plus change in x minus 1 minus change in x, and this is minus 1. Let me take that. Minus 1, put it again, and then let's put this in brackets, and then to be multiplying by their conjugates. So that's x plus change in x minus 1 plus, now since the sign is minus, we put a plus here, x minus 1 over what's change in x plus decrease minus 1 plus change in x minus 1. So therefore, I already know that according to the law of difference of two squares, these two, when they multiply each other, let's put a bracket here, when they multiply each other, you just have their surd out, and what you have is just a real value. So you have here as what? X plus change in x minus 1, and then that's because you take the square of this one and the square cancels out, so it's only just a real value remaining. And then you have what? When minus times plus multiplies, it gives you minus, and then you have this as what? X minus 1 remaining. The surd also cancels out. So here is just what? Here is x plus change in x minus 1 plus change in x minus 1. And this is for your change in y. Okay, now let's now see if we can cancel out any value that's like this, goes out with this. We have a minus sign. Okay, sorry, this is, let's look at this very well. So this is minus x, yeah, this is just minus, so this will be minus 2. I want to be very sure that it's not good, that this is not meant to cancel out. That's why I'm looking at this thing carefully to be sure it's not meant to cancel out. Okay, it's actually meant to cancel out, because if we were to, this was actually in a bracket. Remember, this was minus sign opening the bracket of x minus 1. So here is going to be what? Minus times minus will make it 1 plus 1. So therefore, minus 1 plus 1 will cancel out, it will be equal to 0. Therefore, now this particular one, the new case is now what? Just grad x. That's okay. You're changing x, sorry. And then we have what? X plus change in x minus 1, or your delta x minus 1, and then plus change in x minus 1. Now let's move on. Let me now bring in my divide through by what? By delta x. So change in y divided by delta x. So I do it for all sides, and here's delta x over delta x coming in brackets, change in x plus change in, that's okay, x plus delta x minus 1 plus x minus 1. So therefore, you can see that this one can cancel out this one, right? So what do you have next? You have here as what? Delta y over delta x is equal to what? 1 over, what do you have here? 1 over, here will become what? Okay, sorry, I want to just look at something. Okay. So here becomes what? Still the same thing, x plus change in x minus 1 plus change in x minus 1. Now, when we now take the limits, let's take the limits. Let me take this up again. So when we take the limits, so taking the limit is like bringing in your what? Your dy dx. So dy dx is equal to the limits as change in x tends to 0 of your what? Change in y, change in x, which is equal to 1 over, you have x plus change in x minus 1 plus change in x minus 1. So what happens here? Anywhere you see delta x, you do what? You put it as, you take it as 0, right? That's because it's tending to 0. So therefore, we know that this one becomes 0. There's no delta x again. So that will be equal to that your dy dx is equal to the limits as change in x tends to 0 of your delta y delta x is equal to 1 over, here is then going to be what? X, this one has become 0, so it will be x minus 1 plus x minus 1. Now, you notice that these two are like terms now, so they can add up each other. And when they add up each other, what do you have? You have 1 over what? 2x minus 1. Now, this is the final answer. Whoa, so long, right? Don't worry. When we enter into the chain rule of solving with differentiation, this step that we took forever to do would just take us barely 20 seconds. I think so, 20 seconds. Okay, so that's it. So the next video we'll start talking about the second principle, working with different rules in solving for differential equations. Thank you. Or differentiation. In solving differentiation. Let's not enter differential equation because that's a different topic entirely in solving in differentiation. So okay, see you in the next class.